Hello. In this example, we're going to take a look at how we can use Flowmaster V7 to analyze possible events inside of a simple process system. For this particular model, we're looking at transferring liquid from a low-level reservoir into two higher-level reservoirs. As part of the process, we want to use Flowmaster V7 to investigate the potential effects that operational procedures such as pump startup and shutdown or valve closure may have on the system. With this, we could then determine if these events could cause severe pressure surge or cavitation and help to develop safer standards to carry out these operations to reduce the risk of damage to the system. So if we take a look at the system, what we have is two pumps driving the liquid up to two higher elevation reservoirs, one at 50 meters and one at 40 meters. And what we're going to do is close the valve on the lower elevation tank very abruptly. And at the same time, we want to go ahead and we want to trip the pump to try to reduce the pressure surge in the system. What we can do is we can go ahead and we can run the transient analysis, and using the method of characteristics inside of the pipes, we can look to see how the inertia of the fluid affects the system. So first thing we want to look at is the closure of the valve, and we can see it's a fairly rapid closure, becoming fully closed in only 2 seconds. And we want to see what effect this has on the pressure right after the valve. And so if we look at the pressure on the same plot, what we can see is that we have an initial pressure surge, then dropping down to the vapor pressure of the liquid, in this case water. And then we have several pressure spikes following that. What we want to take a look at is what cavity volume Flowmaster is predicting is being generated at that node. And as we can see, it is predicting several cavity volumes being generated. And as those cavities collapse, it's generating these very large pressure spikes, most above 20. Running the system with constant cavitation and high pressure surges, at best, will result in a much shorter lifespan for the system, and at worst, massive immediate failure. So let's take a look at some of the options we have to try and reduce the pressure surge that we're seeing and hopefully eliminate cavitation altogether. With Flowmaster V7, there's several built-in surge suppression options that you can use. The three that we're going to look at today are a gas admission relief valve, a air vessel accumulator, and a liquid reservoir with a check valve that can open and close to dampen any type of surges. So now we're going to go ahead and we're going to run the analysis. And what we want to do is we want to take a look and see what the pressure is after each of these valves, and basically what the maximum pressure is, as well as the behavior of the surge itself. What we would likely expect is that the system without any type of surge suppression is going to have the highest pressure spikes, and that is actually what we see with these results. And then what we see is from the three different suppression techniques, they have different magnitudes based on the type of technique, but they also have different overall shapes with some more oscillation, some less oscillation. The easy answer would be to pick the one that has the lowest pressure surge, but there's a lot more that needs to go into the decision, including the cost of the different suppression techniques and the physical space available in our real-life system to facilitate one of these techniques. So this is just one example of how Flowmaster V7 can be used to investigate different types of pressure surge situations. If you'd like any more information or for any questions, please feel free to contact your local sales office. Thank you.